Hey guys, Trig day number 5, solving trig equations and verifying trig equations using identities. So all the identities we've collected up to this point need to start to become familiar. You don't have to memorize them, you're going to get many of them on your formula sheet, but you do need to kind of have them in your back pocket and be aware of the different ways to use them. So we're going to do a little bit of that today. Let's get it started. Okay, let's start with example 1. It says, prove that in the given figure a plus b equals pi over 4. Okay, so first place that I'm going to start is kind of with something foundational here, but I know that the tangent of pi over 4 is equal to 1, right? If I consider pi over 4, its tangent would be opposite over adjacent. In this case, I see the side lengths are the same, so the ratio should be 1. Okay, I got that in my back pocket. Let's look at the tangent of alpha. Tangent of alpha would equal 1/3. Okay, and the tangent of beta would be 1/2. So if alpha plus beta equals pi over 4, then the tangent of alpha plus beta should equal 1. Right? If we can assume that alpha plus beta equals pi over 4, then the tangent of alpha plus beta should equal 1. So the tangent of alpha plus beta is equal to the tangent of alpha, which is 1/3, plus the tangent of beta. Actually, I'm going to go back a second here. Let's find the tangent of alpha plus beta and show that it equals 1. Okay, how about that? So the tangent of alpha is 1/3. Tangent of beta is 1/2. Over 1 minus the tangent of alpha times the tangent of beta. Okay. Now, let's see what we get next. That would be 1/3 plus 1/2. Well, 1/3 is, what would that be? 2/6, and 1/2 is 3/6. So I would get 5/6 over 1 minus 1/6. All right, so 5/6 over 5/6, which would equal 1. So that means that the tangent of alpha plus beta is equal to 1. Therefore, alpha plus beta is equal to the inverse tangent of 1. Thus, alpha plus beta is equal to pi over 4. There we go. Awesome. All right. So we utilized the identity tangent alpha plus beta is equal to tan alpha tan beta over 1 minus tan alpha times tan beta. Okay, so that's the identity we had to use there. Let's use a different identity in number 2. It's an interesting question. Suppose that the square root of 3 times sine x plus cosine x is equal to k sine of x plus b for k greater than 0 and b between 0 and 2 pi. Find the values of k and b. Okay, so this is a unique problem. It'll typically come up on a paper 1, no calculator paper. But I'm going to expand this right side, at least partially. Okay, that'd be k sine of x cosine of b plus sine of b cosine of x. Okay, let's then distribute the k, giving us k sine x cosine b plus k sine b cosine of x. Okay, now I'm going to take and equate these two terms as well as these two terms. You'll see why in just a second here. So if square root of 3 sine x is equal to k cosine, I'm rearranging the second term, b sine x, then what would I know about square root of 3 and k cosine of b? They should be equal. And likewise on the other side, cosine of x would then be equal to k sine of b cosine of x. Therefore, k sine of b will be equal to 1. So 1 will equal k sine of b. Now, let me go back for a second. I can equate these terms because of the fact that I've got a sine x here and a sine x here. So this term, if these two expressions are equal, then this term must equal this term, and this must equal this. Okay, I can equate them because of what they have in common. All right, so let's continue. So if I were to solve for cosine of b, I'd have square root of 3 over k is equal to cosine of b, and 1 over k is equal to sine of b. So b is just an angle, and it looks like it's between 0 and 2 pi. Since it looks like k is greater than 0, the sine and the cosine, so if the cosine is positive and the sine is positive, we got to be in quadrant 1. So I'm going to draw myself a triangle. Here's my angle b. The cosine is root 3 over k, and the sine is 1 over k. That right there is telling me I could use Pythagorean theorem or just special right triangles. I see that k is 2. Okay, either way you get there, totally fine. Now, b, the angle, must equal 30 degrees, or we could say pi over 6 radians, whereas k, like we said, is equal to 2. Thus, I mean, we could expand on this and say that square root of 3 sine x plus cosine x is equal to 2 sine x plus 30, or x plus pi over 6. All right, so that's a unique question. You'll probably see that on a paper 1 at some point. All right, let's keep going on a couple more examples here. Okay, problem number 3. It says prove that cosine 3 theta equals 4 cosine cubed theta minus 3 cosine theta. All right, this is going to be an identity, and we're going to use the identity cosine of a plus b. Okay, and in this case, I'm going to use a is equal to 2 theta and b is equal to theta. All right, so part A, I'm going to prove cosine 3 theta equals that thing. So I'm going to write it out as cosine of 2 theta plus theta. So that would be cosine 2 theta cosine theta minus sine 2 theta sine theta. All right, let's expand on that. This would be 2 cosine squared theta minus 1 times cosine theta minus, and sine 2 theta is 2 sine theta cosine theta. So how did I know to use 2 cosine squared theta minus 1? Well, I see cosine cubed here, and I see cosine here. So I see no sines involved. Therefore, I would not use the other two versions of cosine 2 theta, which are these. We haven't used cosine squared minus sine squared much, but you might see that later on. Okay, so let's keep simplifying. This first term here will come out to be 2 cosine cubed theta minus cosine theta. I like the cosine cubed. It's starting to show some promise there. This term, all right, I'm going to nest these. This term will become 2 cosine squared, 2 sine squared theta huh? Cosine theta. Oops, let's make that black. Good. All right, now, gonna get a little fancy here. Sine squared is 1 minus cosine squared. Okay, so here I'm gonna have, oops. Here I'm gonna have 2 cosine cubed theta minus cosine theta minus, this will be 2 times 1 minus cosine squared theta. Cosine theta, are you loving this yet? Because I am. This is great. Okay, keep it rolling. 2 cosine cubed theta minus cosine theta. I'm not going to write so much here. If I distribute a 2 to this and a cosine to that, I'd get 2 cosine theta. And then a 2 to this and a cosine to that, I'd get minus 2 cosine cubed. So I would have minus 2 cosine theta. This is messy, but we'll get our answer here in a minute. Minus another 2 cosine cubed theta. All right, so let's finish it off. 2 cosine cubed minus a negative cosine, 2 cosine cubed. That's 4 cosine cubed theta. And then negative cosine minus 2 cosine theta is a negative 3 cosine theta. There we go. We got what we wanted. Check, smiley face, person doing push-ups, gains. All right, part B. Part B says hence meaning use what you just found to solve this equation. Now, whenever there's a hence, and we're going to use what we have, we gotta root out where it exists. So 4 cosine cubed theta minus 3 cosine theta. That's built right in here. That's 2 times 4 cosine cubed theta minus 3 cosine theta. So I'm going to rewrite 8 cosine cubed theta minus 6 cosine theta as 2 4 cosine cubed theta minus 3 cosine theta plus 1 equal to 0. Now what should I rewrite this as? Well, let's rewrite that as cosine 3 theta. Now this is going to be outstanding because now we're going to subtract and divide. So if I subtract 1, divide by 2, I get cosine of 3 theta is equal to negative 1/2. Okay, now when cosine theta, sidetrack, when cosine theta equals negative 1/2, we know that there's 2 solutions to that on the unit circle, right? So cosine is negative 1/2 here and here. Now if cosine 3 theta is equal to negative 1/2, we're going to initially get those 2 answers. However, we are then going to get 3 times the number of answers that we normally would. Okay, because we're going to divide those values by 3 and then extrapolate them over 0 to 2 pi, or in this case, negative pi to pi. So if you have, instead of a 3 here, if you had a 4 here, you'd get 8 answers. If you had a 5 here, you'd get 10 answers. If you had a 2 there, you'd get 4 answers, right? So as long as your window of possible answers or your restriction is 2 pi units on a cosine or a sine, that will double or triple or quadruple the number of possible answers. So let's work this out. Cosine of 3 theta is equal to negative 1/2. Okay, so where is cosine equal to negative 1/2? This right here is 2 pi over 3 units, and this right here is, let's call it negative 2 pi over 3. Negative 2 pi over 3. So 3 theta will equal 2 pi over 3 plus, hang with me here, I'm going to go with 6 pi k over 3. So I'm going to add 2 pi as many times as I want to. Okay, that's what this is doing. That's accounting for it, where k is a integer value. Okay, also 3 theta is equal to negative 2 pi over 3 plus 6 pi k over 3. All right, and that's going to yield for us 3 answers each. So then theta would equal 2 pi over 9 plus 6 pi k over 9 or theta would equal negative 2 pi over 9. I'm just dividing everything by 3. I'm sure you knew that, but just making sure. Okay, now this theta value here is going to yield us 3 answers. Those 3 answers would be if k equals 0, 1, or 2. So if k equals 0, I get 2 pi over 9. If k equals 1, I get 8 pi over 9. If k equals 2, I get 14 pi over 9. Now 14 pi over 9, since we want our answers between negative pi and pi, just a tricky range of values, that would 14 pi over 9 is negative 4 pi over 9. Okay, so there's the 3 values or solutions yielded by the first one. The second would be negative 2 pi over 9. I add 6 pi over 9 to that, I get 4 pi over 9. I add 6 pi over 9 to that, I get 10 pi over 9, which is negative 8 pi over 9. As you can see, I get 3 negative angles, and I get 3 positive angles. Okay, that's a tricky one, but a good one to kind of hang with. So it's a show that, or a prove, and then a use it with a hence. All right, without using a calculator, let's show that the following is true. Let's show that arctan of 1/5 plus arctan of 2/3 is equal to pi over 4. Okay, anytime you see a tangent and a pi over 4, you should say thank you. But if I took the tangent of both sides, okay, arctan 2/3 tangent pi over 4. Okay, so let's call this, I don't care, alpha. Let's call this, oh wow, beta. Try that again. Okay, so all that those are angles. So if the tangent is positive, let's just, since both of these tangent values are positive and they're supposed to equal pi over 4, they must be acute. So let's put them in quadrant 1. If the tangent is 1/5, right, there's alpha. And the tangent here is 2/3. There's beta. All right, I'm just going to use the tangent of alpha plus beta, which I know is tan alpha plus tan beta over 1 minus tan alpha times tan beta. So that would mean that I would have the tangent of alpha, which is 1/5, plus the tangent of beta, which is 2/3, over 1 minus 1/5 times 2/3. Okay, let's see what that comes out to equal. That's 3/15 plus 10/15. That's 13/15 over 1 minus 2/15, which just so happens to be 13/15 as well. So the tangent of a plus b, or alpha plus beta, is equal to 1. Therefore, alpha plus beta must equal pi over 4. Hey, look at that. I had called this alpha. I had called that beta. I've now shown that alpha plus beta must equal pi over 4. Outstanding. All right, we've got one more question left. It's going to be a previous exam question, and then we'll be good for today. All right, previous exam question, paper 1, which means it's just no calculator. If sine of x minus a equals k sine of x plus a, express tangent x in terms of k and a. So I'm going to expand as I would, sine x cosine a minus sine a cosine x. On the other side, I'm going to rewrite sine x plus a and distribute a k. So it'll be k sine x cosine a plus k sine a cosine x. Okay, I expanded using the compound identity for sine x plus a and sine x minus a. Now, think about what we want to do here. We want to get tan x. That means I want to somehow get sine x over cosine x. All right, so what I'm going to do is I'm going to get these terms, sine x cosine a and sine x cosine a times k on the same side. So that'll be sine x cosine a minus k sine x cosine a. And at the same time, I'm going to bring the sine a cosine x over with this one. So that will be sine a cosine x plus k sine a cosine x. Why would I do that? Good question. Because now I can factor out a sine x cosine a, leaving me with 1 minus k. And on the other side, I can factor out a sine a cosine x, which leaves me with a 1 plus k. Okay, again, you're probably thinking, why? Well, because what I can do now is I can divide both sides by a cosine x. All right, so if I divide both sides by a cosine x, all right, I would get, let's see what we get here. I would get tangent x times cosine a 1 minus k is equal to sine a 1 plus k. All right, I'm close. I've got tangent x, but I want to get tan x alone. So I'm going to divide everything by cosine a 1 minus k. So if I divide this right here by cosine a 1 minus k, I will get tan a. So that'll equal tan a times 1 plus k over 1 minus k. Look at that. I got tan x all alone. I got an expression in terms of a and k. Now I can, in part b, since I've shown something in part a, I can use it with the word hence here. I'm going to use that to find a value or values of x between 0 and 360 if k equals a half and a equals 210. So we're basically just going to solve using what we now know. All right, so if a equals 210, tangent 210, and k equals 1 half. So that would mean that this would be a 3 halves. 1 plus 1 half is 3 halves. 1 minus k, so 1 minus a half would be a half. All right, so tangent x, what will happen here is the 1 half will cancel with the 1 half up there, and I'll just get 3 times the tangent of 210. Well, the tangent of 210 happens to be in quadrant 3, where this is a 30-degree angle. This would be a -1 and root 3. So I would get -1 over root 3 for the tangent of 210. Okay. Reducing this out would be -3 over root 3 or negative root 3. So now looking at the unit circle, where's the tangent negative? Well, it's negative in quadrants 2 and 4. Right, where this would be root 3, this would be -1. This would be negative root 3. This would be a positive 1. So what would these two angles be? All right, the red and the blue. Well, the red angle for x would be 120, and the blue angle for x would be 300. Guys, anytime you see an answer or a range of values given in this degree form, your answer should be in degrees or radians depending on the situation. Okay, that's it. That's day number 5. I would have your formula sheet for all of your identities available as you're working through these problems, and it's supposed to be a struggle, so enjoy it, and we'll see you in the next video. Have a great day.